All right. I'd like to do a couple of examples of solids of revolutions here. This is the problem I did in class, so I just want to refresh. So to find the volume of the solid obtained by revolving the region bounded by y equals x squared and y equals x, and we want to revolve it about the line y equals 0, or the x-axis. Okay, so first thing we need to do is set the two equal and solve. Okay, this is kind of easy to solve. This one is x squared minus x equals 0. This gives you x equals 0 or x equals 1. You could factor and then set it to 0. Now the graph of y equals x and y equals x squared. Let me see if I can use my line maker here. So y equals, so they intersect at 0 and at 1. Y equals x squared and y equals x. All right. So y equals x goes like so. So this is y equals x, and this one is y equals x squared, the parabola. So what we need to do is we need to take a generic x between 0 and 1. Okay, I'll take an x, make a segment, revolve that segment. So we're going to duplicate the segment as if this is our mirror. So that would go from here to here, following the box, the square helps. Okay, so that would be the washer, and I like to get the area of this washer. So we need a big R and little r. To find the big R, the big radius, we just need to find the distance from this point to the x-axis. Okay, and that actually, because the graph is y equals x, this is just simply x. So from the graph, y equals x to the point, to the x-axis, is x units. Little r is from the graph of y equals x squared to the x-axis is x squared. So the area function, the area of the disk, is pi the r squared, which is the big disk, minus pi r squared, the area of the little disk. It's in between. So this is pi times x squared minus x squared quantity squared, which turns out to be at pi x squared minus x to the power of 4. So then the volume is the integral from 0 to 1. That's x could be anywhere from 0 all the way to 1. Okay, anywhere from 0 to 1. So pi x squared minus x to the 4th dx. This is actually pi x cubed over 3 minus x to the 5th over 5. Evaluate that from 0 to 1. That gives you 1/3 minus 1/5 minus 0. You put 0 in for x, you get 0. That gives you 2/15 pi is the volume. The next example is the region bounded by y equals x squared and y equals 4. We want to revolve it about the line y equals 4. So to do the graph, just like before, we're going to set x squared to 4. This gives me x equals plus or minus 2. So when x is 2, y is 4. when x is -2, y is 4. All right, so let's see how we can do the graph and revolve it about y equals 4. Okay, maybe I'll do the graph. I'll use my line maker. Maybe I'll do the graph here. Okay, and shrink it just a little. This is my x-axis. Okay, 1, 1, 2, 4, minus 1, 1, minus 2, 4. This is the graph of y equals x squared. And here's the graph of y equals 4. So this is the region that I like to revolve about y equals 4. So revolving it about y equals 4. So I'm going to revolve it about y equals 4. So take a generic x. I'll take this x. Anywhere between -2 and 2. So you could take it here or anywhere. Okay, and make a segment inside your region. And now we're going to revolve that segment, okay, about y equals 4. It turns out that it goes, so the distance from here to here is just about here on the opposite side. So that's the region that I'm gonna get. That's a cross section. Okay, so that is the radius. I only need one radius because it's not a disk. To calculate this radius, we just have to think a little bit. All right, so like I said before, when we have the x-axis and the graph of y equals f of x, the distance from the x-axis to the graph point is f of x. With that knowledge, I like to get the distance, the length of this segment. This distance is actually the distance from the x-axis up to the graph of y equals x squared. So this distance is x squared. What else do I know? Well, what else do I know? I know this distance is 4 units. So this distance now becomes 4 minus x squared. So the area function is simply pi r squared. This is pi times 4 minus x squared, quantity squared. So the volume is now the integral from -2 to 2 of pi times 4 minus x squared, quantity squared dx. You need to FOIL this and then integrate and put in 2 and -2, take the difference. I'll just give you the final answer that comes out to be 512 over 15 pi, and that's the final answer.